Your pinky toe just found the corner of the coffee table. 1 second you were walking across the room, and now you're not. That fast. That simple. This is second 0, and what happens over the next 60 seconds is something your body has been rehearsing since the first human walked barefoot across a rocky riverbed. Because it turns out, the moment you stub your toe might be one of the most violently coordinated events your nervous system will ever pull off. Let's start at the beginning. The very first thing that happens when your toe hits that corner is nothing. At least, nothing you can feel. That might sound wrong, but it's true. Pain is not instantaneous. It's a message. And messages take time to travel. Here's the thing most people don't know. Your body has 2 completely separate pain highways. And the first one isn't pain at all. In the initial milliseconds after impact, your body sends a touch signal. Not pain, just information. Something made contact. Your A beta nerve fibers, the fast ones, fire immediately. They're coated in myelin, a fatty insulating sheath that lets electrical signals travel at up to 70 meters per second. This signal reaches your spinal cord and brain in roughly 20 to 30 milliseconds, less than the blink of an eye. Before you've had a single conscious thought, your brain already knows your toe just hit something hard. But then comes the second signal, and this one is slower. Your C fibers and A delta fibers, the pain fibers, are mostly unmyelinated. They're bare wires, slow ones. They travel at somewhere between half a meter and 30 meters per second, and what they're carrying is damage data. Pressure so intense it crossed a threshold, tissue compression, potential injury. These signals take anywhere from half a second to a full second to register as pain in your brain, which is why there's always that pause. You felt it. The moment of impact, the brief silence, and then the wave. Scientists have a name for this. They call it the double pain phenomenon. The first signal is sharp and fast. The second is deep and throbbing. 2 messengers, 2 different roads, 2 separate experiences arriving, one after the other, even though they came from the same event. Now, let's talk about what's actually happening at the toe. The moment your toe makes contact, your skin compresses. The underlying tissues compress. So if the force is strong enough, tiny blood vessels in the soft tissue begin to rupture. Not dramatically, but at the cellular level, things are breaking. Your mast cells, the immune sentinels sitting in your connective tissue, detect the trauma instantly. They release a cascade of chemicals. Histamine, prostaglandins, bradykinin. These aren't just immune signals. They are quite literally pain amplifiers. They don't cause pain directly. What they do is lower the threshold at which your pain fibers fire. Your nervous system, which normally requires a significant stimulus to trigger a pain signal, is now primed to fire at almost nothing. This is why your stubbed toe, even after the initial sharpness fades, stays tender for the next 20 minutes. The tissue around it is chemically marinated in sensitivity. But here's where it gets interesting. Around 1 second in, your brain receives the full pain signal and does something remarkable. It doesn't register it. It interprets it. And interpretation is everything. Pain scientists have known for decades that the experience of pain is not simply a readout of damage. It's a construction. Your brain takes the incoming signal, compares it against every prior experience it has stored, evaluates the context, and then decides how much pain to produce. Not how much pain to receive, how much to produce. There's a region of your brain called the anterior cingulate cortex that handles the emotional dimension of pain, the unpleasantness. Not the sensation itself, but the suffering. And this region can be turned up or turned down depending on what your brain decides about the situation. Whether you're scared, whether you're distracted, whether you believe you're seriously hurt. This is not a metaphor. In 2004, a British medical journal published a case report about a construction worker who jumped onto a 15-centimeter nail that drove straight through his boot. He arrived at the emergency room in agony, screaming. When the boot was removed, the doctors found the nail had passed cleanly between his toes. He was completely uninjured, but his brain had constructed a pain experience so real and so severe that he needed intravenous opioids to calm down. Pain is not what happens to your body. Pain is what your brain decides to tell you. Now let's go back to the toe, because things are still escalating. At around 2 seconds in, your brain has processed the signal and issued a response, and that response is not subtle. Your hypothalamus activates. Your sympathetic nervous system, the one responsible for fight or flight, comes online. Your heart rate jumps, your blood pressure spikes, your pupils dilate slightly. Your body has classified this event as a threat and has begun preparing for it accordingly. But here's the part nobody talks about. The part that happens right alongside all of this. The part that is, in some ways, the most interesting thing about stubbing your toe. You swear, not because you chose to, not because you're vulgar or lack self-control, but because swearing under pain is, according to the science, one of the most effective analgesic responses your body knows. In 2009, a researcher named Richard Stevens at Keele University in the UK ran an experiment that has since been replicated multiple times. Participants submerged their hands in ice-cold water. One group repeated a neutral word. The other group swore, repeatedly, loudly. The swearing group could tolerate the pain significantly longer, not slightly longer, meaningfully longer. Stevens suspected it was because the swearing activates the amygdala, the brain's emotional threat detection center, which in turn triggers a rush of adrenaline. And adrenaline, among its many effects, suppresses pain perception. Your nervous system is not spiraling out of control when you let that word fly. It is doing exactly what it was designed to do. The profanity is the medicine. Now, around 5 to 10 seconds after impact, something else is happening that most people never consider. Your motor system has already responded. Long before any of this conscious experience unfolded, your spinal cord initiated a withdrawal reflex. Without waiting for your brain at all, it rerouted the incoming pain signal down a motor pathway and sent an instruction directly to the muscles of your leg. Pull back. Now. This is called the flexion withdrawal reflex. It bypasses your brain entirely. Your spinal cord made an executive decision in under 100 milliseconds to yank your foot away from the threat. By the time you consciously experienced the pain, your body was already moving. You were already pulling your foot back before you knew why. Your brain arrived late to its own emergency. And then, somewhere around the 15 to 30 second mark, your brain does something that is equal parts fascinating and absurd. It starts replaying the incident in detail, the exact angle of the table corner, the sound it made, the half-second warning you almost had but didn't act on. Why didn't you turn the light on? You knew that table was there. You've walked past it 1,000 times. This is your hippocampus encoding the event as a memory. Not because the stub was significant, but because it was painful, and painful events get priority filing. The evolutionary logic is obvious. Things that hurt once may hurt again. Remember where the table corner is. Remember to walk around it. Remember to wear shoes. Your brain is not tormenting you for fun. It is building a hazard map. By the 60-second mark, the sharp pain has typically started to fade. The slow throb takes its place. Your blood vessels, the tiny ones that ruptured, are beginning the early stages of a repair process that will take days to complete. Platelets are aggregating, clotting factors are assembling. The chemicals that amplified your pain receptors are gradually being reabsorbed. Your sympathetic nervous system is standing down, and you're standing there, probably holding your foot, possibly on one leg, having experienced in 60 seconds one of the most intricately orchestrated biological responses your body is capable of. 2 separate pain signals on 2 separate highways. A cascade of immune chemicals reshaping your sensitivity. A spinal reflex that acted before your brain could speak. An adrenaline surge triggered by a single word. A memory being stamped and filed in real time. All of this for a toe. The people who have studied pain for decades will tell you the same thing. Pain is not a flaw in the system. It is the system. It is your body's most urgent and honest communication. And even in something as mundane and maddening as a stubbed toe, the machinery underneath is staggeringly sophisticated. We spend most of our lives trying to avoid discomfort. But every signal your body sends you, even the sharp white-hot ones that make you curse at the furniture, is information. It means your nervous system is awake. It means your tissues are being protected. It means somewhere in your spinal cord, a reflex arc is doing its job so efficiently that your own conscious mind can't keep up. The table didn't win. Your biology did exactly what it was supposed to do. It just hurt a lot while doing it.